Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on oil modeling, compositional oil modeling with PVTP software. In previous video, we have completed this section for boiling point temperature calculation here. We click on or we enable this automate such that we get very small error for the liquid density. Okay, so now we have the molecular weight for our pseudo component and then the specific gravity and also the boiling temperature as the output of the previous computation in previous video. All right, and therefore this is a good checkpoint to do quality check for the current, the pseudo properties, pseudo component that we have defined. All right, so without closing this window, let's go to this tab and then calculation. All right, and then we will find this separator. Click on this one and put the separator on the calculation sheet. All right, so that's the first thing. And then once the separator object is placed on the window, we can simply double click to open the screen. And this is what we have. All right, in this window that opens, we need to enter the temperature and pressure for each separator stage that we have. This can be done manually by either referring to the lab report itself or by, using the PVT sample object. Okay. I'd rather inputting it, manually because it's simple. Temperature for stage 75. This one is 80 psig for the pressure. And the second one conducted in the same temperature, but at atmospheric condition. All right, so that's the separator train input. And then here, chiller train, source of gas for chiller train, no chillers. Okay, and then before the calculation, let me, arrange a little bit. Okay, something like this. I'm gonna make it smaller. Okay, I think it's like this. All right, so we have pseudo properties window, separator train window, and our icons here. Before the separator train can be calculated, the fluid to be used must be first selected, or each of the characterization objects has an output fluid description or equation of state within it, any of which can be used to perform flash calculation. Therefore, this software PVTP needs to know which of the equation state descriptions is to be used for this separator train calculation. And to do that, here we have our pseudo properties window. We are going to deal with this output fluid because we are going to use this fluid for the separator train calculation. So simply, we can right click here because this window belongs to this block, this icon. Okay, so right click here, right click on the pseudo properties, and then choose select. And you can see the green check here. It means that for the calculation, we are going to use the fluid model, or the equation of state defined within this output or this object. All right, you can also do something like choose select from the panel actions, something like this, and then choose this feature, select, and then click on the pseudo properties object. That's the second thing. Okay, so the first approach to do the selection is click on right click and then press select. That's the first choice, or you can also go to panel actions and press this select button and then click on this pseudo properties. That's the second approach. Or the third approach, as the pseudo properties and PVT fluid objects contain the same equation of state, one of the above option can also be done choosing the PVT fluid object here. So you can either select this block pseudo properties or select this PVT fluid. All right, once the desired objects has been selected, it will appear as like this with green tick. All right, now the separator object can be calculated, and to do the calculation, very simple. Just press on this calculate button. So now we have results table and detailed results. Okay, and then go to the results table first. All right, can we expand this? So we have here pseudo properties. The first view is surface results, oil gas results, and surface compositions. Very, very interesting, right? Both for oil and gas composition. Again, this is for oil gas results, for surface results. Now we go to stage results. Okay, and then we can expand this. All right, so here we have the stage GOR of 708. Okay, and then we also have this oil density 835.8. Okay, you see the calculated liquid density at standard conditions using this equation of state is 835.8. This compares quite well with the reported liquid density, which is 814.5 kilogram per meter cube. And the difference is around 2.5%. And then for the calculated first stage GOR, we get this one, 708 SCF per STB, whereas the reported GOR that we have is, 661 SCF per STB in the lab report. Although seemingly very different, this is in fact still within 10%, which is arguably an acceptable match. So both for the first stage GOR, as well as for the liquid density, we have achieved very good match. This good agreement, this good matching is a result of the auto match that we used before. And if we, repeat this process again, but without auto match enabled, the difference, the errors of the first stage GOR and the liquid density will be much larger. Okay, you can also check path to surface objects just like this, just visualization, interesting. All right, this is the source, first separator, second separator, third separator, joint 1, joint 2, this is the outlet for the gas. This is the outlet for the separator, for the oil, I mean. You can also go to detailed results, pseudo properties. The first stage is 80 psig, 75 degrees Fahrenheit. The composition you get, phase properties you get, Hoffman plot you get. Okay, and then for the second stage at 0 psig, 75 degrees Fahrenheit, you get this Hoffman plot, phase properties, composition. Okay, go back to stage result. Here we have, again, 708, which compares very well. If you go to PVT sample, enter lab data, 661, which is very good, right? And for the standard condition, 60 degrees Fahrenheit at 0 psig, atmospheric condition, the data gives, oil density, liquid density of oil, 814.5, whereas in our separator train computation, it's 835, which is very good. All right, so it's a good result. And at this stage, we will also want to access the saturation pressure. Okay, with the pseudo properties that we have defined before. But that's the topic for another day. I think we can call it a day. And thanks so much for watching. See you again in the next PVTP for oil modeling videos. Thank you.